Hi, I'm John at Coach Slade Tutoring, and today we're taking an evidence-based look at what's the best programming language to learn first. This video goes over why this question even matters, what languages are popular right now, pros and cons of a few of the common choices for first language, and research comparing these different languages to each other. I'll also end with some general advice. Now, as you can see, this is a longer video, so if you're busy, just go ahead and use the timestamps in the description to jump to the section that's most relevant for you. Let's get started. So if you search for this question online, you'll find a very common response, maybe the most common response, and people will actually say that it does not matter which language you learn first. And actually, I think the people who say this have some very valid points. Here are 5 reasons people give for why your first language does not matter. And it says, which do you agree with? Tell me in the chat. Obviously, this is on YouTube. I'm recording this for YouTube. I did this in a live format earlier, but there's no chat here, so you can just tell me in the comments, I agree with number 2, I agree with number 4, or if you don't want to get involved with the YouTube comments, I understand it's not exactly known for being a place of sophisticated conversations. So pause the video if you want. Take a minute to read this. I'm not going to read this out. I'll wait for 3 seconds for you to think about this and read them. Pause if you want, and then we'll go to the next slide. So the first one, you can see I agree with most of these, but I think there's a bit more nuance, and even though I agree with these points of why your first language doesn't matter, I actually still think it's quite good to spend time thinking about what your first language is going to be, because, otherwise I wouldn't be doing this video. So the first language is just a vehicle for you to learn the fundamentals, and those fundamentals are what matter. I 100% agree that the fundamentals are what matter. Why? Well, if you don't really know the fundamentals, you're kind of just juggling syntax around, hoping that you're doing the right thing that's going to solve the problem, and that's not going to get you very far. Moreover, you're probably going to learn other languages at some point in your career or in your life. You will have to learn other languages, most likely, and the fundamentals are really what's going to stick with you as you move between languages. And thirdly, if you take a break from programming for 6 months or a year or longer, you'll find that a lot of these specifics of different languages just sort of wash out. You can't remember a lot of syntax, but those fundamentals are what's going to stay with you. So absolutely, number 1, I agree with. Number 2, once you know one language, it's easy to pick up others. Again, I agree with this, but I'd say that some languages are more similar to others, and certain languages are similar to a lot of different languages, so it's worth thinking about that. One comparison I'd give is I find C# fairly easy to understand if you already know Java. Now, that doesn't mean that if you're a Java expert, you're instantly an expert at C#, but it means you're going to pick it up much faster. I might compare it to some real-world languages or natural languages like Spanish and Portuguese. If you already know Spanish, you can learn Portuguese quite quickly, and you probably already understand some of what people from Brazil or Portugal are saying if you already know Spanish. And C# and Java, I think, are kind of like that, so it's worth being aware that some languages are more similar to others, and certain languages like Java or C, for example, kind of gave birth or influenced a number of other languages. And so if you know those, it's more easy to learn. It's easier to learn a number of other languages. Number 3, the market will change, so you don't know exactly what language will be most in demand or what languages will be declining or saturated. I 100% agree with this. So let's think about a situation. You are researching this question. That may be how you reach this video. What's the best language to learn? And so you find some other source that says, the Q language is best to learn. As far as I know, that's not a real language. I just made that up. And so you think that this is going to be the hot language and super in demand in 6 months or a year. I wouldn't trust that source, first of all. But second of all, if you can get that information, so can other people, right? So what if a bunch of other people are also cramming this supposedly hot language? In 6 months or a year, Maybe too many people have learned it and it's oversaturated. Now, maybe that doesn't happen and you're good, but you could also see the market shift a bit, and maybe it's not actually that much in demand, or maybe the person who made that prediction just turned out to be wrong. So you don't really know. Learning the code is a long journey. I'm not going to be one of these people who tell you you can get great at coding and get a super high-paying job within a month. I don't know that that's realistic for most people. So the market will shift, and I don't think basing your decision solely on what the market seems to want right now is a smart way to think about this. So I'd agree with number 3. Now, number 4, can we actually do research on which language is best? And the answer is not really. We can't really define the best in a way that is objective and measurable and meaningful. And we can't really define it in a way that's easy to measure in a controlled setting, but we can define kind of narrower standards and say, for this group of people, in this setting, this language was better at this measurement. And we do have research about that, and later we will look at studies, maybe about 8 or 10 studies in total, comparing some different languages. And finally, number 5, I think we can all agree with, doesn't determine where your career ends up. Other factors like how hard you work, what kind of places you work at, how well you make connections, how good you are at communicating, soft skills, and so on, are probably going to play a much larger role. So given that, we have these 4 or maybe 5 reasons why your first language does not matter, why are we here? Why bother thinking about this? Why not just pick up a language and run with it? So, to me, out of these reasons why it does still matter which language you learn first, number 1 is the most key. Learning your first language is quite a large time investment. We're talking about hundreds of hours, or if you really want to be an expert, thousands of hours. And even though it may not make a huge difference in the grand scheme of things, if you're investing that much time, don't you want to make a smart choice? Even if it's only a small difference, don't you want to make the best choice you can when you're investing that much time? I certainly do, and I'd say that for anything that is going to be somewhat difficult, which learning the code is, and is going to take hundreds of hours, right? We do have some studies, as I mentioned, that we'll look at that take 2 languages and say which one of these is better in this way for this group, and we can use that data to help educate our choice, although they can't completely prove one language is better than the other. It's still useful information, and we will look at that. For number 3, some languages are more suitable for some purposes than others. If you have certain interests, you may move towards certain languages, and that can be quite a powerful factor that's worth considering. And number 4, some languages are better for new coders, or may be better for new coders, I would say so. Many languages just have simpler syntax. We'll compare Java and Python, for example, look at the syntax. You can make the choice for yourself, but I think most people would say that Python syntax is a bit easier to read, for example. Java has other things it's good at, though. And some languages have more appropriate abstractions than other languages. Now, abstraction, this is quite a central concept in computer science in learning to code. So what do I mean by this? What do I mean by some languages have abstractions that are more appropriate for new coders? So let's think about if we want to represent my name, John, John, in a computer program. If you are using old school C, you will represent that as a byte array with 4 items, 4 bytes. And this is quite close to what actually happens inside the machine. It's very, very close to the actual ones and zeros the machine uses. But there's a problem, right? What if I want to add my last name onto this? I'm like, okay, I need to add the last name on and have one long piece that says my first name and my last name. Well, what you'll find in C is that that's not quite as easy as you might expect. You're going to have to get a new array. You may have to copy some things over. You have to worry about things like that. And it's not horrible, but it is a little bit harder than you might expect. What about in Python or JavaScript, for example? Well, there I'm going to use what's called a string. And I just throw some quotation marks around my name, John, and then later to add my last name on, I just use the plus sign, and it's super easy and convenient. Now, inside the computer, pretty much the same thing is probably going on, but I don't have to think about all those details about how big the array is and making a new array and so on. The language handles that for me, right? And it's good because I can focus on other aspects of the problem without worrying about all of the low-level details. Having said that, some people like the low-level details, and certainly some people in sort of the entire system of what goes into a modern computer need to know the low-level details. So C is still worth learning in a lot of ways, but we'll look at that when we get to the different languages. So which languages are popular now? Which languages are popular now? We will look at rankings of what people use. We'll also look at rankings of what professors in computer science programs choose to teach their classes for the introductory level Computer Science 1 and 2 courses. So here are 2 ways to rank which languages are most used. And if you'd like, you can go ahead and pause the video and just compare these. How do the 2 rankings differ? So I'll wait for 3 seconds. I think you'll get more out of this video if you pause it and kind of think about these things for yourself. There's research showing you'll get more if you're more active while you're watching these things. I'll pause for 3 seconds. Have a look for yourself. Okay, so to me, the big thing that sticks out is on the right side. JavaScript is number 1. The way they make these right side rankings, this is the Stack Overflow survey. I believe what they do is they send developers like a checklist, and the checklist has a question. It says, which of these do you use? And you can check more than one box. And so 63.61% of developers said, I use JavaScript. On the left side, it's all the way down at number 6. I find this hard to believe. The left side is based on search traffic in some sense. I'm not exactly sure how they create the left side, but this is another well-known ranking, the TIOBE index. And so JavaScript seems too far down to me on the left. Another thing that makes me seriously doubt how they make the left side rankings, let's look at this, right? SQL, also called SQL, I call it SQL, 2.21%. Visual Basic, 2.18. Basically the same. Are you seriously telling me that as many people are searching for Visual Basic as SQL? I cannot believe that. SQL is super common and it's everywhere. If you've never heard of Visual Basic, you're not alone. It is quite an old language. I mean, a lot of these are, but they're still in use. Visual Basic was on its way out 20 years ago. Right? There's no way roughly the same number of people are getting information for SQL as they are with Visual Basic, right? I just find that sketchy, and yeah, I don't know about that. But these are different perspectives. Like I said, these are both rankings that people use and people recognize for what languages are in use. Now, there's a few languages, HTML, CSS, you can see on the right side. It's not on the left side. And why might that be? Why might that be? Well, there are some languages that are quite useful that we're not going to look at because some people would say they're not typical programming languages. Some people would say they're not real programming languages. And so SQL is the first one of the ones that is quite popular, quite useful, shows up almost everywhere, but we are not going to look at it in this presentation. It's not a general purpose language. So SQL, SQL, apparently some people call it Squirrel. I've read online that people also call it Squirrel, which I think is a really cool name, but I've never actually heard someone call it that in the meat world. SQL is used for things like getting data into and out of databases, and it does some processing and checking of data and stuff like that as well, but it's not a general purpose language. If you write a workout app, you will probably use SQL in some way, but that's not like the main language you're building the app with. If you write a game, your game might use SQL for data, but that's not going to be the main thing you build the game out of, right? So it's not a general purpose language. It is useful. It's good to know, but we're not going to look at that as part of this comparison. HTML is not a programming language. The ML stands for markup language, which means it is used to mark up documents. Basically just, what is the heading? Where does this go? What are my paragraphs? I want to make a list, and so on. Like in this slide, this top thing would probably be an H1 or H2 in HTML. But it doesn't do math. You can't build complex systems just out of HTML. It's used to change how documents look. And CSS is also mostly used to change the way documents look and some behavior. Now, there are people who hacked out a way to make CSS Turing complete, which means it can, technically speaking, do a lot of different stuff that other languages can do. But that was a hack. They were being very clever. That's not what CSS is for. It's for document appearance and some behaviors like what you do on different screen sizes and stuff like that. Now, Scratch is a very popular language for people who are learning to code, especially new learners. What Scratch is a block-based language. Instead of typing all the code in, what you do is you put blocks, and then you connect the blocks together. And this is how you build a program. And actually, you can build fairly sophisticated big things using just Scratch, but it's not commonly used in the workplace, and it's seen as pretty much only an educational language, so we're not going to talk about Scratch in this presentation. Now, what languages do universities choose to use? And is that the same as which languages are popular? You'll see that it's not the same. So this is what universities use for CS1 and CS2. This is what people who choose to teach programming for a living choose to give their courses. You can see this is 409 schools. And what I'd like you to do is, what is one huge difference between those popularity rankings and this ranking? Which language shows up in very much a different place on this ranking than it did on the right side of those popularity rankings? So I'll give you a hint. How many schools out of 409, I believe this is North American schools, chose to use JavaScript? Right, just two. And given how common and popular JavaScript is, that seems pretty crazy. So why is that? Well, I don't really know. I don't know why nobody uses JavaScript for university. I could talk for a while, kind of speculation for why professors who teach this don't like it, but I don't know that that's so useful. Here are the top 4 languages that university courses use for CS1 and CS2. And this is from 2021. I would say maybe Python has jumped to number 1, but I think Java's still almost certainly number 2. If Python has jumped to number 1 now. This was the most recent ranking I could find. I do wonder if they had to stop collecting data for a bit due to COVID or something like that. So yes, these are the languages we'll look at in detail. Java, Python, C++, and C. And we have research comparing these languages to each other that we'll also look at. Now, because JavaScript is so popular, I will give my opinion and some other information on JavaScript. But do be aware, out of all these languages, 1, as a programmer, I have the least experience with JavaScript, and 2, there's not really any research available comparing these other languages to JavaScript for learners. Why? Because it's not, they do the research at universities, and the universities don't use JavaScript so much, so they can't really do research at these universities comparing JavaScript to the other languages, right? So we are getting into looking at each of these languages that we'll consider, and the first language is Java. This is the main language I had when I was an undergrad, and it's a language that for new learners I think has some positives, but also some negatives that you'll want to be aware of. Java, I think, compared to some of the others, has clear behavior. Python and especially JavaScript can often have some funny behavior going on in the background that it's not obvious why it's doing that. It's not obvious what's really going on. Now, Java can still confuse people. Certainly you're not going to instantly know everything that's going on in the virtual machine and stuff like that. But I think compared to the others, it's generally a bit more clear what's going on with Java. But maybe it just seems that way to me because it was, the main language I had for undergrad, like I said. I think Java teaches OOP quite well, object-oriented programming. Now, what is object-oriented programming? Well, I could give a full lecture just on that. Let me know in the comments if you're interested. But OOP is basically like a way of breaking large systems and very large programs down into smaller parts that a human can kind of read and understand and modify and work with. A modern system, your operating system could have 50 million, 100 million lines of code, something like that. It's gigantic. No human has the ability to understand the entire system. So how can we break that into pieces that kind of work with each other that we can understand? Well, OOP, object-oriented programming, is how we do that. Now, if you're learning to code, you will have to learn object-oriented programming at some point. And so Java does this well. I like the syntax for OOP in Java. I think it's easy to read, it's straightforward. And Java is an OOP language. It makes you use objects and classes for everything, and so it does force you to focus on them, and I think that can be good in a lot of ways. In Java, it also makes you use types. Now, what do I mean by types? Earlier I mentioned, how would I represent my name, John, in a program? It would be in Python or Java a string. So this is just some text. It's a way that we represent and understand text when we're writing code. That is different than the number 4. And the number 4 is kind of a different type than the number 0.777. So these are all different types. And some other languages, JavaScript and Python, of the ones we are looking at, don't make you say exactly what type stuff is. Java is taught in a way that does make you say all of these types and learn about these types. And I think that's good for learners. I think you should be aware of these things. Java is quite similar to C#, as I mentioned, and I think being comfortable with what are called C-style languages, which Java is one of these, obviously all the Cs are also like this, it'll make those other languages a bit easier to read and a bit easier to learn. I think Java to C++, is not going to be an easy transition, but maybe it'll be easier going from Java to C++ than it would be from Python to C++. And it's somewhat similar, a little bit similar to C and PHP, although I wouldn't read too much into that. Just in terms of reading it, right? Not really in terms of how it runs and stuff. Java hides dangerous details. Now, what do I mean by dangerous? We'll talk about that more when we get to C and C++, but memory, not letting you deal directly with memory, is one of those dangerous details. And so this is something that you're not going to have to worry about with Java, which will make it easier for you when you're starting to learn to code. Java, I think, does a great job at really putting a focus on necessary data structures like hash maps, lists, arrays, and so on. Python and JavaScript, for example, give you quite convenient ways of working with a lot of these, whereas Java makes you explicitly define and really be aware of these things in a way that I think could really reinforce these concepts for students. Having said that, when I'm saying it makes students learn this, it makes students learn that, from a learning perspective, that can be good. From a getting work done perspective or finishing a project quickly perspective, that's not necessarily good. And so Java is also currently used for the high school AP test, and it's used in many college courses, as is Python. And this is good because there's lots of support materials available for you. You're not going to be walking on this path alone. You can find a lot of materials that are going to be targeted and rigorous materials, thorough materials that are written by people who know what they're doing, that explain things well. But Java has some negatives also. So Java has a few frustrations that, as a teacher of this, as a user of Java, I never thought too much about, but once I was teaching it, they really stuck out to me. The first one that we'll see more on the next slide, the Java input and output just to do simple stuff like reading a character or reading a basic text file, is surprisingly annoying and clunky. And it's not just me who says this. There's a guy named John Osterhout, something like that. He's a Stanford professor. He wrote a book, The Philosophy of Software Design, and he talks in that book about how the Java I/O was designed in a dumb way, right? And you can read the book, but I'm not the only one who thinks that the Java basic I.O. is clunky and annoying and hard to use, and he would say it also exposes more information than it needs to. So we'll look at that more on the next slide, but you'll see it's quite a dramatic difference, this versus Python for basic input and output. Java is known for being quite verbose. Again, we'll look at that on the next two slides, so I won't explain here. Java, and really all of these compared to Python, don't read closely to normal English. Now, what do I mean by this? So Python was designed to read quite easily. Java and the others, not so much. So let's say I have like a container, a group of items, a container of items of some sort. It doesn't matter which exact type of container. And in Python, I want to check, is the number 7 in this container? In Python, I just say, like, if 7 in container. Quite easy. Like this word in, that's kind of what we'd say in normal English. In Java, you would have to say something more like, if container dot contains parentheses 7. So it's not quite as close. My students and a lot of people feel that Java is dry, and what a lot of people say is that it simply has far too many rules. You feel like it's always finding a rule to make your code not work, and it can be a bit frustrating. There's lots of things to pay attention to, and it does just kind of have a dry flavor that not everyone likes. There are quite a lot of learning materials, and that is a positive for Java, although I'd say all of the languages we're looking at have plenty of learning materials. I think the Java materials are not quite as fun as the Python materials or the JavaScript materials, but that's just my opinion. I'm sure you can find fun stuff for Java, but I feel like the fun stuff is easier to find for Python and JavaScript. Some people say that Java is on the decline. They say that new systems, new projects are not being made in Java as much as they were 10 or 15 years ago. Having said that, Java is still common enough. And Java does not teach the true low-level fundamentals as well as C or C++ does. It is not close to the metal, close to your processor in your machine in the way that C and C++ are. And Java, this is just an annoyance. I've never liked this. You have to put everything in a class, and each class gets put, at least every public class gets put in its own file. You end up with 3 or 4 files for very simple programs that are just very simple class projects. It's good to learn how to deal with multiple files, how to organize and keep track of multiple files. I don't know if that's something you need to worry about right at the beginning when you're learning to code, and I've always found it annoying. So let's have a look at this top point, the I.O. being a bit harder than it really needs to be. So we're not going to read over this in detail, but this is using Java to open a file and print its first line. This would be a simple text file, and you'll notice that this is a solid 10, 12 lines. We're not going to read over this, but look at how big this is, right? A lot of lines. Look at how long some of these lines are. Another thing, look at all the brackets. Look at how deep in terms of nesting you have to go just to write this simple code. This is a lot to keep track of. As I said, I'm not the only one who thinks they set this up in a kind of clunky manner. So look at how big all that is. Compare it to the Python that does the same thing. Right? Like, which of these looks better to you? Which one do you really want to learn? To me, it's an obvious choice. Now, Java has other things going for it, but just for this and for a lot of things, the Python is just a lot shorter, a lot easier to read. Now, some of you might say that the Python does not do exception handling, which the Java did. The Java makes you do that. In Python, that's optional. But even if I added the exception handling in case something goes wrong when reading the file to the Python, it's still going to be much shorter than the Java was. And this is another comparison chart. This is Python 2. You'd want to go with Python 3 now, but it's very much the same idea. There's not too many differences between their example code and what the Python 3 would be. And this is from a paper from 2015 that we'll look at more in a bit. But look at the Java column. It's a bit longer. Notice, too, that the Java column so much wider than the Python column, right? I don't know. To me, this is just a clear indication that Java can be verbose. There's lots of things to type in. Even if you're just using tab completion to do all this, I think it's still bad because it's still more to read, and it's still just more space in which to make a mistake. It's more space in which to find a potential mistake. So even if you're using tab completion to do some of this for you, I still think it's better to have a language that's less verbose, at least for people who are learning. So Python. Now, Python has a lot going for it. I quite like Python. As a programmer, it's my favorite to use, and I'd say as a teacher, it's probably also my favorite to teach. So Python has more readable syntax. I gave the example earlier of using the word in to check if a container contains some item. And related to this, Python is just much less verbose. You can get more work done with fewer lines and less typing, and that makes it easier to read in a lot of ways as well. I think Python has lots of fun projects for kids available. Now, if you're watching this, you may not be a kid, or, even if you're younger, you may not think of yourself as a kid. That's fine. I actually think the kid projects are quite fun to do and can really help you learn a lot and enjoy it and be motivation for you to learn more. And so I think it's great that there's fun projects for kids and for other learners that are commonly available in Python. And Python hides a lot of low-level details. Now that's a pro and a con. It's good to learn these things, but if you're trying to learn quickly, if you're trying to finish something quickly, this is something that Python does well. It hides these details so that you don't have to worry about them. And Python is hugely popular now. It has many different uses and many libraries. Now, why is this good? Well, pretty much anything you might want to build, you can build in Python. And people will say, oh, well, that's true of the other ones too. To some extent, but Python has good libraries that are well maintained, that are easy to use to do a huge number of different things. If you really want to build a game or a machine learning system or whatever using nothing but C, of course it's possible to do that. But you're not going to be able to do it as quickly as Python, and if you run into a roadblock, if you get confused about something, the support for these other languages for doing so many different things isn't necessarily as good as it is for Python. Now, the different languages do other stuff, and there is plenty of support material for doing certain things, but I really think Python has quite a wide reach in terms of what it can do and in terms of the libraries that it has to do these different things. And Python, out of all these, I think is the easiest to interact with. It's quite easy on Python. Now, the others have this too, but I don't think it's as good as the Python one. It has what's called a REPL, a read-eval print loop, REPL. And you just open this up on your computer, you start typing and it runs the code. It's instant, it's very fast feedback, which means you're learning faster. You're running through a feedback cycle much faster, and you can experiment very freely. You can really have fun with it and learn a lot. Now, as I said, the others, like Java and JavaScript, do have this, but I still think the Python one is better than those. So, the negatives for Python. Now, you'll notice Python does not have so many negatives, but it has a few, so let's go over these. Python's easy syntax can hide some details that students will need to learn at some point. What's an example of this? Well, Python gives you a very convenient, very easy to use dictionary type, just built in the language that you get from day one. And dictionaries are great, and everybody loves them, but at some point it's necessary to step back and say, what is a dictionary really? And what happens inside there? And inside there is a hash table with some different optimizations to make it run faster and keep insertion order and save memory and stuff like that. But it's a hash table, and students need to be aware of what hash tables are and how they work, and it's necessary to kind of look at that and examine that in detail. And in Java, for example, they make you call it a hash map, and they make you say what the types are for the key and value and stuff like that. And it makes you really think about what's going on a bit more than Python does. Having said that, the Python dictionaries are super easy to use and pretty much everybody loves them. This second point, what is really going on here? Python, it has a way of presenting things in a quite simple, readable, nice way that we all like. Maybe not all of us, I like it. But actually there's a lot of weird stuff going on under the hood. If a student were to ask me, as they have asked me in the past, what is a class really? In Java, I find this easy to draw out on the whiteboard, and I can explain it in a fairly straightforward fashion. In Python, a class as it exists while your program is running is an object. But what is the class of that object? And what does it mean for the class while the program is running to be also an object? And then there's also objects of that class. This isn't horrible, but it is not as obvious as Python makes it look. There are things going on under the hood in Python. Everything at the end of the day is an object in Python. But, it can be surprisingly difficult to answer these questions for some things. Python doesn't really teach types well, right? So Java makes you think about these and is taught in a way that makes you think about these. Python has type checking, but it doesn't force you to use types, and most of the learner material does not focus on making people learn and use the type system. People kind of attach that on later after they've already done a boot camp or a course, and even when you do use the types, it doesn't really make you use the types. So I think Java has a better focus on types than Python. And some people say if you really learn to code using a language that doesn't make you learn types, it can form bad habits later on. I don't know if that's true, but that's what other computer science educators have said. And in my opinion, the Python OOP, it's perfectly good for learning OOP. It does have OOP, but I don't like the syntax that Python uses as much as I like the Java syntax from a conceptual level, or maybe the C++ syntax. Python doesn't really have privates either, and I do think privates are useful to know and learn when you're learning OOP and to understand why we have privates, why we need privates, stuff like that. So I think C++ and Java force you to focus on OOP concepts a bit more than Python does. But having said that, you can learn OOP in Python. And so we have plenty of research comparing Java and Python, as you might expect given that those were the two most common languages taught at universities. So we'll just quickly go over some of these results. We've got a 2023 study that basically, how do they make these studies, you might be wondering? Because I said it's kind of hard to define what's best in a way that's measurable in a controlled setting. So the controlled setting here is generally that some university has a bunch of students taking Computer Science 1 and or Computer Science 2, and they want to do a study about languages. And so they take, say, 100 of these students, and they split them into two groups. One group will get Java, one group will get Python, and then they measure them in different ways. They might give them a concept test that's sort of language agnostic at the end of the semester. They might also measure things like how many syntax errors do they have when they compile their code, or how many times do they have to resubmit a given assignment, because if you submit one time, hey, you got it right pretty quickly, you understood well. If you had to resubmit 32 times, okay, that was hard for you, that was a headache, right? So they can measure things like this. And so in the first study, it was syntax errors. And so they found that Python just has fewer syntax errors, so that indicates the syntax may be easier. And that's good. You can worry about the syntax less, focus on the concepts and the fundamentals that I mentioned more. The second one, again, it's an older study, and this actually compared Python to a number of other languages, several of which had C-style syntax with the curly brackets rather than the indentation that Python uses to define code blocks. And they found that Python has syntax that people make fewer mistakes with as compared to the other C-style languages they looked at. And C, this one took a different approach. This is a textbook analysis. So what they did here was they got a number of Python textbooks and Java textbooks, and they kind of ran, I guess, like a word count for different concepts. They figured out how many times these different textbooks mentioned different concepts, and they found that the Java textbooks mentioned core concepts more than textbooks about Python. And some people might say this suggests a better focus on core concepts in the Java books. I don't know that I'd read too much into that. It is kind of a different approach to making a study. But the textbooks did seem to mention these fundamentals a bit more than the Python textbooks, but I don't know, I wouldn't read too much into that one. Here's an older study, and this would have been, I think, given the time for Python 2, but they found that Python's simpler syntax meant fewer errors, and they found actually fewer logical errors and fewer syntax errors, so that's nice. And finally, this one is the one that had the chart we looked at, the chart with the 2 columns. This is from 2015, and they said that the Python learners had a better understanding of core concepts. The idea here is that maybe because the Python group had to spend less time learning the syntax, they could kind of spend a bit more effort and time learning these core concepts. So maybe Python does have, Python learners, the Python groups had a better understanding of core concepts. At least that's what they found in 2015 study. So C++ is going to be our next language, and C++ definitely has a few things going for it, but some quite serious drawbacks as well, as you'll see. One thing that draws people to C++ is that it's quite fast. C as well. And many people just like to have code that runs really, really fast. They like to optimize for speed. This is attractive to a lot of people. And if you like that, you'll definitely want to look into C or C++. And these are not slightly faster than the others. They're much, much faster in many cases. They can be 10 times faster or even 100 times faster in some cases. So if you want to go fast, look into this. And C++ does a great job with both high-level and low-level concepts. You can look at very granular, sort of bit-by-bit details with C++ that really represent quite closely what's going on in your computer as you run the code, but it also has high-level stuff as well. It really captures both of those. And C++ is great for teaching object-oriented programming. To me, this and Java kind of have the best focus on OOP, and they include all these central OOP concepts. So it's great for that. And, C++ is how I initially learned a lot of that stuff, back in the day. It was my first language, not recently when I started learning to code. It's been a while, makes me feel a bit old, but, they made high school kids learn C++ back in the day, which they were different times. Unlike Java, you can make standalone functions. I have always found it annoying in Java that sometimes I have a function, it's just doing one simple thing. I want to make just a function. I don't want to figure out how to connect this to some class, even if it's a static class. I just want to make a function. Why can't you just let me make one function? I've always found that annoying in Java, and C++ will let you make a standalone function. And I think just the basic I.O. looks nice in C++. I've always liked it. When you read in a variable, it has these nice arrows that kind of point into the variable, cin, arrow, variable name. It's putting it into the variable. I've always liked the way that looks, and I do find it a little bit easier than the Java I.O. we looked at, although maybe not quite as easy as the Python one. And for a lot of people, a big draw for C++ will be that it is commonly used to create AAA big-budget gaming titles. And so for a lot of people, they want to get into that industry, and so this may be a big draw for them. And C++ has been around for quite a long time, I think roughly 1980. I don't recall the exact year, but there's lots of libraries, and there's lots of learning resources available. Do be careful, though, because some of these may be out of date just because it's been around for so long. But C++ really has a lot of negatives as well. So it is by far, out of the languages we're looking at, I think the most complex. And it's known for being complex and difficult and tricky. And so I mentioned, you need this high-level and low-level knowledge. You really need to understand a lot to use C++ well. You have to kind of know both the high-level things, the organizational things, and low-level things, right? And so that means you really have a lot to think about, and it can be quite a lot for a new coder to get a handle on. And I don't think it's as readable as Python. I don't think any of them are as readable as Python, but some people would disagree with that. But actually, I don't know. Modern C++, I learned it over 20 years ago at this point, and I look at the modern stuff, and it looks ugly. I don't know how else to say it. It looks quite chunky. There's lots of double colons everywhere. I think most people would say it's a lot less readable than Python. And what people really say about C++ is that it's dangerous and it's difficult to use correctly. It gives you many ways to shoot yourself in the foot. So C++, as I've mentioned, is a huge, complex language. It has many different ways that you might approach a given task, but they're not all right, and some of them are outright dangerous. One of the dangerous areas that I've mentioned, manual memory management. If you're not careful here, it can crash your code. It can crash your code in a way that's difficult to find later. It can also be a security issue. And this is just easy to get wrong, right? So it is an issue, and most modern languages don't let you play with memory in kind of a manual, direct way, the way that C and C++ do. And so keeping track of all these issues, the high-level and low-level knowledge, the different ways to shoot yourself in the foot, the memory management, that may be too much for a new programmer. That may be too much. There's a bit of research comparing C++ to the others. This study from 2018, which surprised me, found that the Python learners struggled more than C++ learners on the exercises. And I guess in this study, the way they measured that was that the C++ learners needed less time to solve a given problem. That's surprising to me, but it is just one study. And the language choice, here, this was an interesting one because they studied online programming courses. I think that's probably relevant for a lot of people watching this video. And so they found that there was no significant difference in outcomes between C++ and Java. You'll notice this study a bit older, but I think for intro-level material, just for the intro level, probably not a huge difference in 2013, so I think that's still relevant. And like I said, a lot of you are probably learning stuff online, so that's a nice, relevant study for you guys. C. C is the oldest out of these languages, and it's been around a while. You'll see that it's time-proven. I looked it up. Apparently, it was invented in 1972, so it's 52 years old when I'm making this video. And some people say it stood the test of time, and maybe that means it'll still be around in another 50 years. Will it? We don't know. Will the robot apocalypse come and kill us all? Maybe. We'll see. Positives. So C has a small core language. You have to be good with the core language. You have to understand what's going on. But there's not a lot of bulk. There's not a lot of different concepts and things that you have to master and memorize right at the start. There's less bulk to learn, right? It's just a simpler, more stripped-down language. It's close to the metal. It's close to the hardware. It's easier to see what's really going on in the computer, and for a lot of people, that's appealing. You can there's not levels of abstraction. They're kind of hiding what's really going on. It forces you to learn these low-level principles, memory management, and data types. And it's good for that. I think if you are really interested in if you're the type of person who takes things apart and wants to know at a very granular level exactly how each part works, exactly what each part is doing at any given time, C may be a language that really appeals to you. To me, I think about C as this next point, code up data structures from scratch. If you build your own hash table in C, you will learn a lot. It's quite a useful learning exercise, and a lot of the other basic data structures you can kind of build up yourself too, and see them working in the hardware and at a low level very directly, and that's quite rewarding. It's quite a great learning activity. It's not necessarily great for getting work done quickly, though, but it is good, and I would compare it almost to building with hand tools. That's the comparison I like to go with. if you're going to make, a picnic table using a saw and a hammer and stuff like that, you kind of have a very direct feel for why each part needs to be there, for why each part is the way it is. And you have a direct feel for it and, a sense of achievement as you've constructed this simple but useful thing for yourself. I think C can be like that sometimes. And it's still at the heart of our operating systems. The most common version of Python is actually kind of built around C. It's built on top of C, CPython. So it's still used in many things. And many, many languages evolved from it. Obviously, anything with a C in it kind of came out of this. Sometimes people will ask, what about a B language? What about a D language? Those were around at some point. I don't know that people still use them. I want to say they actually got to F, and there are still a small number of people using the F languages. But, don't quote me on that, right? I didn't look that up recently. Now, C has some negatives as well. So C is not good for learning OOP. I say not good. It doesn't really have OOP in the way that the others do, right? So you can kind of simulate some things that OOP does in C with stuff like function pointers and structs, but it's not really the same thing, and it's not going to transition to other contexts or other languages quite so well. And forcing you to learn all these low-level details, it may make it harder to get basic projects working. For many people who learn, getting a project finished is hugely motivating. They want to have something they can look at and be proud of or show other people. C will not help you to finish stuff as quickly. And kind of jumping down to this point, in JavaScript or Python, it's quite easy to build something that you can run on your phone quite easily or run on a website and show to all your friends. And for many people, that's fun and motivating. But for C, many of the projects are just so low level that you're not really, you'll show them to people and it kind of just looks like a blob of text, and they're like, no, you're like, no, it works properly. It's impressive. It took me 3 weeks to build this, and people are like, right? I'm sure there's some online system where you can sort of build stuff with C to where it looks nice, but I think in general the projects that are commonly available for Python and JavaScript are just a bit easier to show off. And this kind of relates to that too. I do think some of the other languages have just more choice of different learner activities that are a bit more fun. The pointers and memory management are easy to get wrong, as I've mentioned, and hard to fix. Everybody who's done C knows the segmentation fault. It doesn't tell you, line 42 is wrong and crashed your program for this reason. It'll just say segmentation fault. You're like, oh, right, and then you have to find it, which if you know what you're doing, you can, but, if you're learning to code, you're not necessarily going to know how to deal with that, and it can be frustrating, right? So C actually, I think, as a learner language, does have a lot that's going for it, but you do need to be aware of some of these other issues. So we have, I could only find one recent study on C, and so it was pretty conclusive, right? It was C versus Python from 2018. Python learners have better outcomes on every measure except dropout rate. Now, what were those measures? Fewer failures, higher grades, more completed assignments, and fewer submissions per assignment. So that is just one study, but it seems quite conclusive. What I'd say in defense of C, I like C too in some ways, as you can probably tell. What I'd say in defense of C is this. Let's say two people are learning to cook, and they are making pasta, spaghetti, with sauce. One person goes to the store, buys a jar of sauce, boils the pasta, dumps the jar on. The other person makes their sauce from scratch. Now, if they're both really new at this, maybe the person who made the sauce from scratch, it's okay, it's not great. It's not quite as good as the store-bought one. Now, who knows how to cook better? Well, I'd say the first person, the person who bought the jar, Python, in this comparison, the way that's a bit easier to use and that hides a lot of details. Maybe their pasta does taste better. Maybe their code looks nicer and runs a bit better, but do they know more? I would say not necessarily, right? Not necessarily. And so I couldn't find that many studies, so I'll just give you guys a nice quote. It's a well-known quote that's been around for a while. And it says, if programming in Pascal is like being put in a straitjacket, then programming in C is like playing with knives. And programming in C++ is like juggling chainsaws. So Pascal we didn't talk about. It is a bit of an older language. It was the main educational language in a good bit of the 80s and into the 90s. There are still a lot of people who know and use Pascal, but not so common anymore. I would say what they say about Pascal, you could say that about Java, right? It can feel very restrictive and too many rules. It feel like it has too many rules. C and C++, you're trying not to hurt yourself, essentially, and they're dangerous, right? And so what would Python be? Now, this last part I just made up, but in this sort of knife juggling comparison, what would Python be? The closest thing I could come up with, and this is just fun, this is just something I made up, maybe it's like using a turkey slicer. You could hurt yourself, but it's fairly safe. It gets a lot of work done quickly. It's easier to use. So I'd say maybe Python's like a turkey slicer. So JavaScript. Now, as I mentioned, JavaScript does not have so much research about it. I mean, I didn't find too much, and we're not going to go over any. And out of these, JavaScript is probably the language that I'm the least experienced with. So these are kind of things that I just gathered from reading some stuff online and a little bit of personal experience. JavaScript, at least at the basic level, does not have, it's not as verbose as Java. Right now, as you move up, I think it probably gets a bit chunkier. And Java is quite tolerant of errors. Java had a very different approach to kind of people typing things in wrong and people making mistakes as compared to these other ones. The other ones say, like the statically compiled ones like Java say, you type in one thing wrong, the wrong kind of syntax, I will not run any of this. Python kind of says, I'm going to run some of this depending on which mistakes you made. But if I may reach a line where you made a mistake, and I'm going to stop running it at that line. Other types of mistakes in Python, it won't run at all. JavaScript said, well, I don't really care about mistakes. I'm going to do the best I can. I see that you did something wrong, but I'm going to try and make it work. And so what this means is that you can make some mistakes, certain types of mistakes, and your JavaScript will still run. But is that really a good thing from a learning perspective? Well, maybe not, but we'll look at that on the negative slide next. You don't need to know low-level details. JavaScript originally was made to run just in a browser. You don't have to worry about, low-level stuff like, is this integer like a little tiny 8-bit integer? Is it signed or unsigned? Stuff like that. C, C++, you can deal with all that. JavaScript, you don't have to worry about that. And due to the above 2 points, I really think you can learn faster and get programs running faster and get projects that you can show to people working faster. And, that's this point, right? You can build a lot of things that are easy to show off. For many learners, that's a huge motivator. You can learn OOP with JavaScript. I have not taught OOP with JavaScript, but it's in there, right? And it's just so widely used. It's really critical in web development, and it's used for other things at this point as well. I don't think it's going anywhere. I think it's just way too widespread to disappear within the next few years. I think it's too widespread to really disappear. I don't want to say at all, but I don't think it's going away anytime soon. So it's probably a safe bet. But having said that, a lot of people do know it already. It may be a bit saturated. So what about the negatives for JavaScript? Many people say you're going to need a lot of external frameworks and libraries that you're going to have to take time to learn. To get work done, you just need more of these sort of external frameworks, and you have to spend your time to learn these. And some of these people say may not be well maintained, or they may change in the future, so even though you've spent a lot of time learning them, you're going to have to continue to learn other stuff, and that's true with all of these. Okay, that's true with all the languages, but people say it's worse with JavaScript. I don't know if that's true or not. If you think that's not true or that it's more true for the other languages, feel free to tell me in the comments. JavaScript has this fail silently concept. So sometimes JavaScript you have a mistake, JavaScript will try to run it anyway, and it has strange behavior. It doesn't obviously crash. That's bad for a learner. Why? You kind of want to crash to tell you that you're doing things wrong. You don't want your code to seem to work, but you don't understand what exactly it's doing. That's a problem for a learner. You can imagine a learner who makes some mistake. JavaScript responds to this in a certain way, and they think, when I do this in this wrong way, JavaScript does this, and then later they start deliberately making the mistake or something like that. For a learner, this can kind of be a bad pattern to get into. And I suspect that's part of the reason why they don't use it at universities. JavaScript does not teach types. TypeScript, a different, kind of a related but different language, does have types, but we're not talking about that in this talk. And JavaScript hides many low-level details, so it's not as good for learning these low-level concepts. Academics don't like it for whatever reason. I'm not sure about the reason. I mean, I do remember when I was in college, some professors mentioning that it's a horribly designed language and they don't really understand how it ever got popular. But it's easy to use, and I think you have to say maybe it's popular for a reason, right? And so a lot of people say JavaScript teaches bad habits. If it's your first language, maybe it's teaching you kind of suboptimal ways to think about things, to do things that may have an impact further on. We've got a couple honorable mentions. I didn't put as much work into researching these. These are just other languages that I have a bit of experience with that I think might be okay choices. PHP is commonly used in WordPress in back-end stuff, and it had a bad reputation for a while. It was known for being kind of questionable, but people say it's gotten better, right? And the syntax seems easy enough if you already know Java or C#. It does have the brackets and stuff. It's not exactly the same, like the dot is used quite differently, for example, in PHP as compared to Java. And I think maybe one of the drawbacks here is that it's just not used very often as a first language. Now, I'm sure there's courses available, but it's not commonly taught as a first language to the extent that the others are. And so maybe there's not as many learning materials available. Now, C# seems okay to me. It seems readable, seems quite tidy, quite close to Java. Some people say it's strongly supported by Microsoft, and that's a good thing. Other people say it's too dependent on Microsoft, and that's a bad thing. So, I don't know, different perspectives. It is also used in game development in Unity. So if you're looking to get into game development, but maybe you don't want to tackle sort of the beast that is C++, you might have a look at C#. But again, these two, I've used both of them a little bit. I haven't taught either of them. So this is just honorable mentions. So that's all the languages we're going to look at, and I've got some general advice for you that is not specific to any one language. So if you or your child, if you're watching this as a parent, has some specific interest, like you want to do one specific thing, you want to build some specific project, I think just choose the language that does that. Building projects is a great way, maybe the best way to learn these things. And if you're really passionate and motivated about building some specific thing, if you're very interested in it, not just interested but fascinated by some particular project or application, just choose that. I really think that these are all good choices. Everything we've looked at is a reasonable choice. And in view of that, I really think the motivation, enthusiasm you have for that project easily outweigh all the other factors. So if you have some specific interest that you already know about that really motivates you, just go with the best language for that thing that you want to build. If you already have a course in mind, like it's cheap, it's near you, you like the teacher, if you're still in school, that's just what your school offers, just go with that. It'll be fine. I do think convenience is a big factor. We're all pressed for time. And if it's convenient or you just like that instructor or something, go with that language. These are all okay choices, as I said. Number 3, in 5 or 10 years, we don't really know what's going to be in demand, if anything. Maybe AI is doing it all for us, and there's a completely different skill set that's going to make you money or help you build the things you want to build. We really don't know. We really don't know. So don't worry too much about the long-term picture. I mean, the fact that you're learning to code is part of taking care of this long-term picture. But in terms of what specific language you need, I don't know that we really have any reliable information about that. And so for most learners, I really think the biggest motivator is being able to get a project working quickly, see it working, and feel proud of it. And kind of depending on your personality, you may really want to show it to your friends. You know, maybe you want something that you're at a party or at an event and you say, I'm learning to code, I built this. You can pull out your phone, you can show them right away. Or you can have them open it on their phones, even better. For many people, that's a huge motivation. And so I think being able to build things and get them working quickly is something we should keep in mind. And in view of that, I really think Python and JavaScript are great choices. I think these are the two that will help you get something you can show off working the fastest. And so for me, if you have no other preferences, you haven't really gotten any ideas or made a choice yet, I think Python's a great default. You remember it had the fewest negatives on its slide. I think it's super readable, and it's a great choice. And out of these, I want to say it was the only one that was specifically designed for education. The guy who made it, he's known as Guido van Rossum, I think is his last name. I'm sorry if that's wrong. He did design educational languages like before Python, and it was like a big factor in how they created this. And I think it shows, but it is used quite widely, far more than just in education at this point. I think JavaScript is a perfectly good choice. I think it must be popular for a reason. It is super common, and it's easy to get projects you can show off working quickly. It may form some bad habits, as I mentioned, but just be aware of those things. And you know, maybe all of these languages have things going for them, strikes against them that may be clunky, that may not transfer, and so on. I really think JavaScript is a perfectly fine choice, even though universities don't commonly choose to teach it as the first language. Now, if you are interested in low-level hardware, if you're interested in how do things really work, what's really going on at a granular, detailed level, if you like building things with simple tools, building with hand tools, if that idea appeals to you, I think C is a great choice. I would like to learn more projects in C. I've done it in the past. I don't have time to kind of continue building things in C at this point, but I think that really granular understanding is tremendously interesting and valuable. So if you like that low-level approach, I think C is a great choice. But some people are just built a bit differently in kind of the problems and challenges they choose. Some people want to see something that is vast and complex and intricate and tricky, and they say, I want to master that. I want to defeat that. That's not most people. But if you're one of those people, I think that's awesome. And I think you can choose C++ for your first programming language. And I've taught Java the most out of all of these, and I learned it and used it for many years. But it's difficult for me to see what unique advantages it has in comparison to these others. Now, I think it's a perfectly fine choice, but aside from teaching basic OOP, which I do think is important, I don't know that it has any distinct advantages. Having said that, these are all okay choices. So, I hope that's enough information for you guys to make an educated choice. My name is John, I'm at Coach Slate Tutoring, and I am a computer science educator. I do private lessons, and if you're interested, check me out. You can email me or check out this website. For YouTube, I have some other content available. It is mostly animated videos about different computer science concepts, basics like hexadecimal, some algorithms like quicksort. Check that out if you're interested. And if you did watch the whole thing, love you, really appreciate it. You know, I do work hard making these. My voice is even getting scratchy from spending so much time reading this. So thank you. I appreciate you. Have a great day.